W1VLF.
Folks, we're loaded up and we're going to head off to a local pond to do some testing on the micro beacon. Two distances, 300 feet and about 700 feet, and if that works out, we'll find a further distance to go. Bear in mind it's daylight we're doing this contact, and also it's a single LED and no amplification on the photodiode end. It's just a photodiode driving right into a 50 ohm load where it really wants to be, into a really super high impedance load. So this is an absolute bare bones minimum sort of beacon. It'll be transmitting at 20 kilohertz, a steady tone, so it'll be easy to find. So we'll head out and give you more details, and I'll set up again at each of the locations to see what we can hear. Okay, we've arrived at Bull Pond here in Harwinton, Connecticut. The first site is going to be that sign out there that shows you some information about the paths around here. The second site, that's about 300 feet. The second site will be somewhere in the neighborhood of those pine trees. There's a sign out there. I don't know if you can see it or not. Anyhow, let's take a quick look at the transmitter. Okay, I don't have it on right now, but the transmitter is that oscillator circuit for $9.99. The beacon here is not in service right now, so just in case I can't find the signal, I want signal to be on all the time, running at 20 kilohertz. And we're sighting through this tube because the LED here in the front, and that's our transmitter. Where the hell is it? Let me just zoom in a little bit on it. That's our transmitter right there, that single LED, and it's only running probably at 10% of its capacity at 20 kilohertz. And there's our 300 and, I don't know, I got it written down in my pocket here, 300 feet, and there's another one at 600. If this works with reasonable amount of signal, I'm going to find a place that's even further away. So I'm off. Okay, we're at our first site, which is 300 and, let me see, 333 feet away. Sorry, it's a lot of sun getting in the way. Let's see. Anyhow, 46, 47, up to as high as 48 dB out of the noise. Again, no amplification whatsoever on this side, and we are just about pointing right into the sun. Here's the receiver. It's just a projection television lens, maybe 3.5 inches across. There goes the 12 o'clock alarm. Let's see if I can, and there's the diode. Just a plain old diode. I can show you which one it is if anybody's interested, sitting in the middle of the beam here, being focused by this lens. Let me squeeze that back down. And the way I'm holding this on is just some 1/4 inch 20 steel threaded rod, and adjusting the distance between the lens to put the photodiode right in the center, in the focal point. So again, there's the noise floor, and 46 to 47 dB out of the noise. And if I move off frequency, the needle drops to 0. So we're suffering from a gain problem here right now, right? And I don't know what's going on with this signal to noise ratio there, but anyhow, you can hear that. And we're going to move on to our next site, which is over there on that little land bridge. Okay, we are now around 750 feet away from that little diode out there. I don't know if you can even see my car. It's so sunny, we're shooting almost directly into the sun, so sure that's not helping any. I can't see it on my phone. Okay, there. I guess I was zoomed all the way in. There's the transmitter, and there's the sun. And we are still at, let me try to get rid of some of that sun. Well above the noise. Again, broad daylight. It said 46 before, now we're at 33. How much can you trust that? I don't know. But very, very simple test here. Now, just imagine if you had that LED running at full power. You know, it's rated for 100 milliamps with a CW tone, so that's 50 milliamps with a 50% duty cycle, and it's running about 10 or 15 milliamps right now. And if you had a better lens, which could gather a lot more light, you weren't pointing into the sun, and maybe if you had, like I have at home, 140 of these LEDs running 2.5 amps of AC current, 5 amps for the 140 total. Darn that sun. Okay. Let me see if I can bring this up a little, if that's better. Nah, you're just getting reflections. Oh, I went to sleep. Went to sleep again. All right, so anyhow, that's the scoop. The other thing is that little square wave generator out there is running an LC circuit. I looked up the chip that's on it. It's running an LC circuit, so it is not super stable. Maybe I'll come back out with a crystal controlled oscillator, which would be much better. Well, I'm gonna see if I can grab one more site here. Maybe out at 1,000 feet. I don't know. I'm going to look around. I'll be back. Okay, well, we're out at the same spot, the 800 foot. Actually, it's 800 because of where I moved my vehicle back. So 800 feet. And I showed you those changes I made. But just to reiterate here, in case when I'm editing this I forget, I added an FET to switch the LED on and off. And by doing that, I was able to take the actual current that the LED is consuming from about 4 or 5 milliamps up to about 50 to 75 milliamps. And back here we were at an S2. So let's take a look at what we got now. Got an S6. So way, way above the noise floor. Modulated, that would be an easy copy. Now, it's getting a little bit darker. Again, this is not full sunlight, but huge difference, right? From an S2 to an S6. This is stronger than I had at the 300 foot level. So, anyway, I'm going to post this. The next thing I think I will do is probably put a rifle scope instead of that sight tube. because at 6 degrees wide, I'm still not 100% sure I'm pointed exactly in this direction. Anyhow, wanted to make a second trip out here, so 800 feet, right? So now I'm looking for places where I can go, where I can get out to 1,000 or 1,500 feet. What I'd really like to do is be able to make it to 1 kilometer. That would be a legitimate contact with an ultra simple system like this. You just have to put a Morse keyer in series with the LED to turn it on and off. All right, W1 VLF freezing his butt off here, headed back home.